Hey guys, how's it going? So, it's time for our first online lecture. You guys ready for this? Yay! So this whole thing's kind of crazy, but CUNY is kind of a mess right now. Well, Lehman's doing pretty good, but Baruch, there's not much collaboration going on. Lehman, all the staff is working together, and I have yet to hear anything from anyone in Baruch. So I'm just kind of doing my own thing. The only thing I'm worried about right now is how the final is going to play out. So I hope people start making moves at Baruch, and hopefully our semester will go by smoothly. All right, so our goal for today is to cover something called the chain rule. We're going to start off reviewing what we know about derivatives and then work our way towards it, all right? So let's start right here. The first rule that we ever learned about derivatives, at least the shortcut version for derivatives, is called the power rule. And if you guys remember, the power rule was given something like this. If we have a function which has a base of x and it was raised to some power n, then the derivative of that function, in order to find the derivative, all you gotta do is drop the exponent down and then take 1 away from it. So for example, if our function here y equals 3x squared, to find the derivative, we drop the exponent down, that's where this 2 came from, and we took 1 away from the exponent. 3 times 2 is 6. 6 to the 2 minus 1 is just 1. So our answer is 6x. So for a function 3x squared, the derivative of that function is 6x. Okay, good. That should be a review for almost everyone. Now, let's take a look at this guy. We have y equals 2x plus 1 we have y equals 2x plus 1 squared. So note that for this guy, our base is not x. See how in this previous one, our base was x? In this one, it's not x. Instead, it's a function of x, right? It's like something multiplying x and then adding or subtracting it. So in other words, we don't have x raised to the second power. We have a function g of x, which equals 2x plus 1 raised to the second power. So we can also rewrite this guy like this. Y equals some function of x, which is g of x, which in this case is 2x plus 1 to the second power. So how do we go about finding the derivative for something like this, where it doesn't have a base x, but it has a base of a function of x? Well, what we're going to do is follow this similar pattern, where the derivative of y with respect to x, what we're going to do is we're going to attack the exponent first. We're going to drop the exponent down, just like what we did in the previous step, and take 1 away from the exponent. Now, the only hiccup here is we have to multiply this whole thing by the derivative of this inside function. Okay, we have to take the derivative of that guy. So for this example, let's see. So we're talking about this function, by the way. We have y equals 2x plus 1 squared. So we drop down the 2 and we take 1 away from 2. Remember, g of x is that inside function, which is 2x plus 1. And now I'm going to multiply by the derivative of this inside function. So if g of x is equal to 2x plus 1, then g prime of x, which is the derivative of g, is 2. So I multiply this guy by the derivative. See? And if I simplify this whole thing, I get 8x plus 4. Now what we did here is called the general power rule. So it's pretty much the power rule, but if you don't have a base x, rather than having a base x, you have a function of x, you're going to do the normal power rule, but then multiply it by the derivative of that function, which is the base. So another way Actually, before we get there, here is the general power rule formula written in math notation. You have a function h, which equals g of x to the nth power. The power rule is going to work pretty much the same. So you drop down that n, take one, you drop down that n, take one away from it. The only difference here is because it's not x, it's the function of x. Then we multiply it by g prime of x. So the general power rule is just an application of what we call the chain rule. Okay, and before we start talking about the chain rule, we have to remember something called composite functions. So we actually went over this earlier in the semester. Composite functions are when you put one function inside another function. So for example, if I have f of x, if I have one function named f here, and he equals x squared, and I have another function here called g, and he equals 2x plus 1, then the composite of the two, f of g of x, is equal to 2x plus 1 squared. So all I did here was I took this guy and I put him inside this function. I replaced x with g of x. Then the chain rule says to take the derivative of such a composite function. I'm on this sentence right here. If to take the derivative of a composite function, you take the derivative of the outside function, but leave your input as g of x, not x, and multiply this whole thing by g prime of x. So it might sound confusing, but it's a lot simpler than it seems. Actually, we kind of just did it anyway. So here, for this example, f of x is x squared. Then the derivative of this, using the power rule, is 2x. Okay, so they want us to find f prime of gx. So we have f of x, then we have f prime of x. Now we need to find f prime of g of x. So all we do is replace this x right here with g of x. And g of x is equal to 2x plus 1. That's all coming from over here. So we have this final statement where f prime of g of x is equal to, I know this is getting messy, this whole thing right here, 2 times 2x plus 1. Now, the next thing they want us to compute for the chain rule is this, g prime of x. Well, if g of x is equal to 2x plus 1, then g prime of x is 2. So I have this, and I have this. To find the derivative of this composite function, I just multiply these two things together. So I multiply this guy and this guy. So ultimately, to find the derivative of this composite function, I multiply them together and I get 8x plus 4. And this is exactly what we got in the previous result right here. We just thought about it in a different manner. One, we thought of it as a composite function, and one, we just taught it as like the general power rule. I mean, we did the same thing, it's just a different approach. Okay, so the way I like to think about the chain rule is it's not very mathematical, but it gets the job done. So I think of the exponents kind of as guards to the function I want to differentiate. So if I have something like 6x to the second power, and I would consider this guy, the 2, the guard, and this guy, the function I want to attack. So I have to differentiate this, I have to differentiate the guard first before I differentiate the function. So, well, you'll see what I mean in a second. All right, so let's do this example real quick. where we have y equals the square root of 5u squared minus 9. All right, so first thing I'm going to do is I'm going to rewrite this function. Right now I have a square root there. I want exponents to pop up. So I'm going to rewrite him as 5u squared minus 9 raised to the 1/2 equaling u. Okay, and now let's differentiate. So I'm going to find the derivative of y with respect to, what's my variable here? Not x, it's u. So be careful with that. Remember, if we differentiate to a variable that's not there, meaning if I were to write this instead, dx, this whole thing would go to 0. Remember, we did that on the first day of derivatives. So make sure we're differentiating with respect to the right variable. So it's du here. And we're going to attack the guard first. Okay, so let's differentiate this guy. What we're going to do is we're going to attack this guy, but we're going to pretend that this guy, so we're going to pretend that our function looks like this. And so if I were to differentiate this, I would drop him like that. But because we don't have a base of x, our base is actually this thing. I'm going to replace x with 5u squared minus 9. 5u squared minus 9. Okay, so I've already attacked the outside. I differentiated the outside. Now my goal is to differentiate the inside. So the inside is 5u squared minus 9. If I differentiate this guy, I get 10u using the power rule. So this whole thing will be multiplied by 10u. And this is what the chain rule says. Or even if you think about this, it's easier to think about the general power rule. I attack the exponent first, and then I differentiate the inside. I differentiate the exponent first, then I differentiate the inside. And that's exactly what we did. I differentiated the exponent first, then we differentiated the outside. Oh, Jesus Christ, I keep messing up. Then we differentiated the inside. I gotta say, it's kind of weird teaching with, just me and my cat in the room. It's kind of awkward. I wish I was actually teaching people. Anyway, we can go ahead and simplify this whole thing now, right? So do some math, and it will simplify to what? 5u divided by square root 5u squared minus 9. Remember, this square root goes in the denominator because there's a negative right here. So 5u squared minus 9 raised to the 1/2. Let's come over here. Equals square root of 5u squared minus 9. However, 5u squared minus 9 raised to the minus 1/2 is equal to 1 over square root of 5u squared minus 9. Either way, this is our final answer. Okay, so I'm going to make a separate video where we're going to do 3 more, and then, yeah, we'll call it a day.